Hello viewers, in today's class we are going to discuss one important definite integral involving the signum function, right? And here we have to find the value of this integral that is from 0 to pi, and the integrand is signum of cosine x divided by pi plus x, right? So let us start and let us first call this integral as I, right? So here we see that the integrand involves the signum function, right? So let us quickly revisit the definition of signum function. We define signum of x as a positive 1 whenever x is greater than 0, right? So for all x which are positive, signum of x takes the value plus 1, right? And signum of x takes the value 0 whenever this x is equal to 0, right? And the signum of x takes the value negative 1 whenever x is less than 0, that is when x is negative, right? So we'll use this definition to first simplify this integral. So now see here the lower limit is 0, right? So the lower limit is 0 and the upper limit is pi, right? And between 0 and pi, we have pi by 2, right? So this is 0 degrees, this is 180 degrees, and between 0 and pi, we have 90 degrees, right? Now let us come to the sign convention of trigonometric functions in the four quadrants, right? So this is the first quadrant, this is second, this is third, and this is fourth, right? So here we have 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, right? And here we have signum of cosine x, right? And let us concentrate on the limits of integration. So here we have the limits from 0 to pi. Let us split this integral as a sum of two integrals, right? So the first one is from 0 to pi by 2, and we'll see why we are splitting this integral into two parts. And here we have dx, and then the second integral is from pi by 2 to pi, and here we have signum of cos x divided by pi plus x dx, right? So here we have split this integral as a sum of two integrals. At this point, this is the breaking point, that is pi by 2, right? So when we go from 0 to pi by 2, it means we are confined in the first quadrant, right? And in the first quadrant, cosine x is positive, right? In the first quadrant, when we go from 0 to pi by 2, cosine function is positive. So this quantity is positive, right? That is inside the signum function symbol, right? So this cos x is positive in the first quadrant, that is from 0 to pi by 2. So signum of cos x takes the value plus 1 when we go from 0 to pi by 2, right? And when we go from pi by 2 to pi, it means we are now confined to the second quadrant, right? And in the second quadrant, we know that the cosine function is negative, right? So here cos is positive, here cos is negative. So when we go from pi by 2 to pi, then signum of cos x is negative 1 because cosine x is negative, right? So when x is greater than 0 or positive, signum of x is plus 1. So here cos x is positive, so signum of cos x is plus 1. And when signum of x is negative 1, it implies x is less than 0, so cosine x is negative, right? So now we can write these integrals as 0 to pi by 2, and here we have plus 1 over pi plus x dx, and here we have pi by 2 to pi, and signum of cos x is negative 1. Here we have minus 1 divided by pi plus x and dx, right? So now we have two simple definite integrals, and we know that integral of 1 over say a plus x dx is equal to log of a plus x, right? And here this log is the natural log, right? So in the first integral we have log of pi plus x, and the limits of integration are from 0 to pi by 2, right? And here we have negative sign, and we have log of pi plus x, right? And the limits of integration are from pi by 2 to pi. So now we can simply substitute the limits and we'll take the difference. So in the first one, we have a log of pi plus pi by 2, pi plus pi by 2 minus log of pi plus 0, right? And in the second integral, we have here a log of pi plus pi, and then we have log of pi plus pi by 2, right? So let us simplify this expression. So here we have log 3 pi by 2, then we have log of pi, right? And here we have log of 2 pi, and here we have log of 3 pi by 2, right? So now we can apply the properties of log here. We know that log of m minus log of n is equal to log of m divided by n, right? So here we have log of 3 pi by 2 divided by pi, and in the second term we have log of 2 pi divided by 3 pi by 2, right? Okay, now here we can cancel this pi and this pi, so this is 3 over 2, and here we have log pi and pi get cancelled, so this 2 goes to the numerator, so we have 4 over 3. So again, applying this property, we have log, and this is 3 over 2 divided by 4 over 3, right? So this is log 3 by 2 multiplied 3 over 4. So this is a log of 9 over 8, right? So viewers, the value of this integral is equal to log of 9 over 8.